Hello, my name is Ajiboye Isaac, and today we want to look at application of trigonometry. Emphasis on elevation and depression is a continuation of our previous lesson. Okay, so learning objectives. At the end of the lesson, learner should be able to satisfactorily represent angle of elevation and depression. Apply trigonometry and right angle triangle to solve problems of elevation and depression problems. Okay, in our previous lessons, we have learned trigonometry, especially sine rule, cosine rule, Pythagoras theorem, and trig ratio in right angle triangle. So we want to apply this knowledge to solve problems of elevation and depression. Content, angle of elevation. Angle of elevation is the angle measured between the horizontal line, horizontal level of the eye, and the slant line of sight when an observer looks up to see an item. On the other hand, angle of depression is the angle measured between the horizontal level of the eye and the slant line of sight when an observer looks down to see an item. So the difference between the two is that one is looking up, the other one is looking down. The one that is looking up is called elevation. The one that is looking down is called depression. If there is an hunter that wants to aim at a bird on a tree, as the hunter is looking at the bird, it is angle of elevation. Okay, while the bird will also be watching the hunter. Okay, so the angle at which the bird is looking at the hunter, because the hunter will be looking down to see the hunter. Don't forget the bird is on the tree, so the bird will be looking at the hunter. The angle at which the bird is looking at the hunter is called angle of depression, because the bird will be looking towards down to observe the hunter. You know, that kind of a scenario. So elevation and depression. If you look at the diagram we have there, you can see in that diagram, we have Mr. A and Mr. B in that diagram, right? And Mr. A has horizontal level high, so also Mr. B. They have horizontal level. We have horizontal eye level for Mr. A, horizontal eye level for Mr. B. Now, they are both looking at one another, right? So, the angle between the horizontal eye level of Mr. A and the line of sight of Mr. A is alpha, and that is what we call the angle of depression. On the other hand, Mr. B is looking up to Mr. A, okay? And you can see that if we represent that angle by theta, that angle is what we call angle of elevation. Watch, notice, take note that that angle is between the horizontal level and the slant line of sight. Do you notice? It is not the vertical line. You will not put the angle between the vertical line and the line of sight. It will be wrong. It is between the horizontal level of the eye and the line of sight. Okay? So, from the diagram, it is important we observe that the angle of depression of Mr. A and the angle of elevation of Mr. B are alternate angles. Okay, those two are alternate angles. That is, angle alpha and angle theta are alternate angles. We call them Z angles because it seems they form a Z. Meanwhile, alternate angles are equal, right? Alternate angles are equal. So we can say that if two persons are watching, observing themselves, right? One is up, one is down. The angle at which the one on top is observing the person down will be equal to the angle at which the person down is observing the person that is up. They are always equal. Okay? However, they also form a right angle triangle. Note that the vertical height and the horizontal height level are perpendicular, and hence they form a right angle triangle. We can therefore apply our knowledge of trigonometry of right angle triangle to solve problem of angle of elevation and depression. Example: the angle of elevation of the top of a tower from a point on the horizontal ground 80 meters away from the foot of the tower is 60 degrees. Find the height of the tower. You know, this is a practical example, something that you can always do. If you know the angle at which you are looking at the top of a house, right? And you know your distance between where you are from the point where you are looking at the top of the roof of a house and the foot of the house. You know the distance. Then you can easily calculate the height of the house. It's very simple. Okay, so representing that in a diagram, let h be let the height be equals to h. So we draw the tower, the vertical height, and the foot of the tower. Then we represent the 60 degree as angle of elevation. Represent the 60 degree as angle of elevation. Okay, so I told you that whenever you have a right angle triangle problem, the first thing to do is to label the sides. So hypotenuse has been labeled, adjacent is labeled, and opposite to the angle 60 degrees is labeled. So that will now help us to know which of the trig ratios to use. So using trig ratios, we'll see that we have the adjacent, we want to find the opposite, and we know the angle. So the most suitable trig ratio to use is tangent. That is, tan 60 is equivalent to the height over 80 meters. So if you cross multiply, the height will be equal to 80 tan 60. And remember that tan 60 is root 3. Therefore, our height will be 80 root 3. Solve the example. The angle of elevation, okay, from 2 points x and y, 8 meters apart, in line with a pole, the angle of elevation of the top of the pole at 30 degrees and 60 degrees respectively. Find the height of the pole, assuming that x and y are on the same side and same horizontal level with the foot of the pole. So this is also a practical example, an electric pole, all right? And two persons are observing the top of the electric pole at different points. So it is obvious that definitely they will have two different angle of elevation because they are at different points, right? So that's what the question is. But they want us to use this information to find the height of the pole, right? So we represent that. We draw the pole, okay, and then represent the angle 60 degree from y. 60 degrees is the angle of elevation of the top of the pole, and 30 degree is the angle of elevation of the top of the pole at x. Okay, so if we represent that on a right angle triangle, we have triangle TYF, that is T is the top there, and we have also we have two triangles there. We have triangle TYF. We also have triangle TXF. And if we represent fx, the distance between f and x, f and y as a, and the distance between f and x as b, it will be clear that b can be represented as a plus 8 because the distance between f and x is the same as adding the distance between f and y and the distance between y and x. So our b is 8 plus a plus 8. So from the triangle TYF, okay, that is, you can do it. I didn't do it because of, having to manage the space that I have here. Okay, if you draw triangle TYF and you label the sides opposite, hypotenuse, and adjacent, you will see that tan 60 degree will be equivalent to h over a. So making h subject, h is equal to 8 tan 60 degree, and that is equivalent to a root 3 because tan 60 is root 3. So h is a root 3. From the triangle TXF also, tan 30 degree is also equals to h over b. All right, so if we cross multiply, our h will therefore be equals to b open bracket 1 over root 3. That is tan 30 degree. I told you to make a note of that summary of the special acute angles that I did for you in a previous class. You will notice that tan 30 degree is 1 over root 3. And I told you that you will always nationalize when you have sod at the denominator, so that our h will be equals to b open bracket 1 over root 3 times root 3 over root 3. And on simplification, our h will be equals to b root 3 over 3. Now, the h in the triangle TXF and the h in the triangle YTYF are the same. It's the same height of the pole. So if we equate the two heights, okay, we have a root 3 to be equals to a plus 8, open bracket and close it, root 3 over 3. So all we need to do now is to make a subject. Open the bracket on the left-hand side, on the right-hand side, and collect like terms. So our a root 3 minus a root 3 over 3 will be equal to 8 root 3 over 3. A is common, so you collect like terms. You factorize. So a open bracket root 3 minus root 3 over 3 will be equal to 8 root 3. So all we need to do now is to make a subject. That is by dividing both sides by root 3 minus root 3 over 3. So our a will now therefore be equals to 8 root 3 over 3 divided by the bracket root 3 minus root 3 over 3. Then close the bracket. So, and that will be equals to, when we simplify the fractions in the bracket and then, change the division sign to multiplication, it therefore means our a will be equals to 4. And recall that our h already has been stated to be a root 3. So all we need to do is to replace a to be 4. So h will be equals to 4 root 3. That's the final answer to that. So this is our classwork. Please attempt the classwork and forward your attempts to me. The first thing to do is to first draw the angle of depression. Draw the vertical line representing the cliff. Okay. Then draw the angle of depression to represent the angle of depression to the boat. And then you know that you will form a right angle triangle. Label the side of the right angle triangle. Determine which of the trig ratios to use and find the distance between the boat and the foot of the cliff. Do the same thing for question 2 and forward your attempts to my WhatsApp number. Do not hesitate, okay, to ask questions if you have any. And I'll be here. If you send every step you take to me during this lesson period, I'll definitely respond to them immediately. So don't be shy to attempt. Don't be afraid to write, to make mistakes. Just attempt. Make sure you attempt and forward your attempt. Okay? Then at the assignment as well. Attempt the assignment and forward your attempt of the assignment to me. I'll be more than willing to answer your questions if you have any. I'll be more than willing to correct if there are any irregularities in your attempts. But I expect you to send your attempt. Thank you for listening.